We've already seen that we can take a 3D shape and we can flatten it out into a net. And when we flatten it out, we end up with a load of 2D shapes. For example, with this cuboid, that's rectangles joined together. Key thing is though, when we flatten a shape out into its net, whatever shapes the faces are, they are 2D shapes, which means that the net is also two-dimensional. Now that means that while the 3D shape has certain physical properties, like for example a volume say, if we flatten it out into a net, the shape can take on a new property, because this net can have an area. It can have a certain amount of space inside it. And surely the area of a net will just be the area of the individual shapes that make up the net. The areas of the individual rectangles here, for example, in this cuboid. If it was the net of a triangular prism, say, it would be the areas of the rectangles and the triangles that make up the net. This that we're talking about, the area of a net, we can give that a proper name because it's actually quite a useful property. And the area of a net is called the surface area. And we might need to find the surface area for any of the 3D shapes that we've looked at. But all it comes down to, if the surface area is just the area of the net, all it comes down to is, step 1, work out what 2D shapes make up the 3D shape, and step 2, find the area of each of those. Because the area of this net would just be all of the individual face areas added together. Let's have a look at an example. Work out the surface area of the cuboid. So the surface area of the shape means that we have effectively flattened this shape into its net. We're then going to look at the net and find the area of the net. But we can do that much more simply by simply taking all of the faces and working out the areas of those. Once we've added those up, that's like us saying, here is the net made up of these different faces, these different 2D shapes. Find the area of each of them, add them up, that would give us the template, the net that this shape is made from. So the first thing we're going to do is we're going to sketch out the different faces. We're going to sketch all of the faces and we're going to put the measurements on them. So we are going to have, well, first of all, we're going to have the front and the back. Let's do the easy ones first. So we're going to have this front one with the 5x4. That's 5 across and 4 in height. And that's the front. And we're also going to have the back as well, which will be the same. We are also going to have the left and the right. That's this one and the one on the opposite side. So that's left and right, and they are going to be 3x4, each of them. And then we're also going to have the top and the bottom. And they are going to be 5 across here and 3 by this side. So that's 5 and 3. 6 faces sketched because the cuboid has 6 faces. Top and bottom, left and right, front and back. We simply need to work out the area of each of those, however we normally would for that kind of shape. So for a rectangle, we simply need to take the across measure and the up-down measure and we times them together. So that means the area here will be 4 times 5 is 20 centimetres squared. The area for the base, in fact, will be the same. It will be 20 centimetres squared as well. For these left and right faces, well, the area there will be 3 times 4 is 12 centimetres squared each. 12 centimetres squared for each of those. And finally, the top and bottom, the areas here will be 3 times 5 is 15 centimetres squared for the top and 15 centimetres squared matching that for the bottom. To find the total surface area, all we would need to do is add up all of those individual areas. So the surface area will be 20 plus 20 plus 12 plus 12 plus 15 plus 15. Add those all together. 20 and 20 is 40. 15 and 15 is 30, so that's 70, plus the 12 and 12 comes to 94. 94 what? Well, in spite of this being a 3D shape, we are talking about surface area. We've been looking at areas all the way through, so our units are going to be area units of centimetres squared, and the surface area, 94 centimetres squared. Whenever we look at surface area questions, it's important first of all to make sure that we have the correct number of faces that we are considering. If a shape has 5 faces, we need to be sketching 5 two-dimensional shapes. It's often the case that certain shapes will be repeated within the 3D prisms, so we don't necessarily have to work out individually the area of 5 different faces, but we do have to have numbers for each of those. It's also important to make sure that we transfer the measures correctly, that we match up the right sides to the right faces. And it's important that we work out the area of each individual face however we normally would for that shape. So if we have a triangular face, we have to make sure that we're working out the area of that triangle the way that we normally would for a triangle. If we're looking at any sort of other shape, we have to make sure that we are working out the area of that face however we would for that shape normally.